the concept of efficiency. This is efficiency in terms of energy. So this is becoming more and more important at the moment, because the more efficient an object is, the less energy is wasted. And the less energy is wasted, the more useful energy we can get. And this depends on something called the law of conservation of energy. And that states that you can't create or destroy energy, you can just change its form. So I can change 200 joules of, let's say, electrical energy into 200 joules of kinetic energy. But I can't just create 200 joules of kinetic energy out of nowhere, or I can't just get rid of 200 joules of electrical energy. So this is quite an important concept, because when you have that energy going in, some of it will come out as wasted energy, so stuff you don't want. So if I give you an example we're going to use the idea of a light bulb. Now, a light bulb has electrical energy going into it. That electrical energy is going to then turn into light energy. So that's the energy we want to get out of a light bulb. You don't want to get heat out, and you don't want to get sound out. Now, you might get a little bit of sound from the vibrating of the filament. I can maybe think of a couple of examples, like in an easy bake oven, where you do want heat from the light bulb. I can't really think of any reasons why you might want sound. So we're going to assume in the next question that sound and heat are wasted energies. The useful energy is the light, and we calculate the efficiency using this formula. So the useful energy divided by the total energy that goes in, sometimes multiplied by 100 to get a percentage. What I would do is I would find out this value and then multiply it by 100. So let's have an example question here. So I'm going to highlight the numbers before I even read it. So you've got 200, 10 and 40. And then we read the question. So a light bulb receives 200 joules of energy. It loses 10 joules of that energy as sound and 40 joules as heat. What is its efficiency? So let's just have a quick look. The total input from the electrical is going to be 200. And that's joules. Now, the wasted, because as we've stated, the heat energy and the sound energy are wasted. So that's going to be 40 plus 10. So we're going to have 50 joules of wasted energy. However, you'll notice that neither of the two variables you need are wasted energy. So I need to figure out the useful energy. And because the same amount of energy coming out is the same as the energy going in, total useful, so adding together wasted and useful energy, should equal 200. So in order to get my useful, I'm going to do 200 minus that 50 from the wasted, give me 150 joules. Okay, now I don't need the wasted anymore because it's not actually in the formula. So what I'm going to do is I'm going to do the calculation again. I'm going to put these numbers into the calculation, and my efficiency is going to equal my useful, which is 150, divided by my total, which is 200, and then that's going to give me 0.75. Okay, and then if I want to multiply it by 100 to get a percentage, I'm going to have 75%, and that's my efficiency. Now there's a very simple practical you can do at home to show this. If you get several different types of balls, so for example like a squash ball or a football, tennis ball, or squash ball is actually perfect for this because its efficiency changes depending on how hot it gets. So if you just bounce it once when it's cold, it will have a different efficiency to bounce if you bounce it several times quite hard just to warm the ball up. Now I would get a tape measure or a meter ruler. You could even do this with a 100-centimeter ruler or a 30-centimeter ruler if you want to do the calculation that way. And you hold the bottom of the ball up to the top of the ruler. You drop it and you measure. You might need to do it a few times to get an accurate average, but you measure the height to which that ball bounces, again from the bottom of the ball. If you want to do it from the top, that's fine. You start at the top of the ball and you measure it from the top of the ball. When you do that, the total energy input, the total gravitational potential energy is the height up here, and the useful energy will be the height of the ball on its bounce. And what you do is quite simply, if this is the case, using this as an example, the useful energy here was 60, the total energy was 100, and we're doing it in centimetres here instead of talking about joules, but it's the same concept, times 100. And you will have an efficiency for this ball of 60%.